Here are the answers to Unit 6 free response question B. Unit 6 involves integration topics. So the first question wasn't meant to be a trick question, but a lot of people got it wrong for a silly reason. You're supposed to take the antiderivative of the function on 3 different intervals and use a left Riemann sum. So whether it was intentional or not, the trick came from the fact that the second 2 intervals are each width 4, but the first interval is width 3. So when you go to calculate the base times the height, the first base needed to be 3 units. The height is just the value of the left endpoint plugged into the function. So 1 plugged into the function gives you 4 over 1 squared. 4 plugged into the function gives you 4 over 4 squared, and 8 plugged into the function gives you 4 over 8 squared. And then again, like I said, the second 2 bases were each 4. So adding all those together, you get 53 quarters. Part B asks you to find the antiderivative. Show the work. So there's a very straightforward problem. One of the things that I like to do is, instead of using the quotient rule, which you don't even need to do here, I take 4 over x squared and turn it into 4x to the negative 2, and then apply your rule that says increase the exponent by 1 and divide by that. And that's the same thing as negative 4 over x, which is the same quantity they get right there. So once you get that antiderivative, substitute the values 12 and 1, subtract the difference, and get 11/3. Third question asks you to take the antiderivative, but this time with an infinite quantity as one of the limits. So this falls in the category of improper integrals, and the way that you deal with the improper portion is you change the question to a limit. Take the limit as b approaches infinity, and now you have definite limits of 1 and b. Antiderivative is the same. When you take the limit as the last step, 4 divided by a very large number is 0. You wind up with 4. And then the last question throws a natural log inside the integrand and asks you to find that value again from 1 to 12. This is testing you on integration by parts. If you don't have the integration by parts formula on your formula sheet, I would copy it down and label it. You have a choice as to which is going to be u and which is going to be dv. It makes sense to have the natural log be the u statement, because taking the derivative of natural log is a little bit easier than taking the antiderivative of a natural log. And then dv is going to be the f of x part, because we've already taken the antiderivative of 4 over x squared, so we're just going to use that again in our dv statement. Plugging all that into the integration by parts formula, uv minus v du, antiderivative v du, simplifies down to this statement here. You don't really need the plus c if you just jump straight into evaluating the antiderivative at those endpoints, 12 and 1. A little bit of an algebra simplification, but your final answer is that or something similar to that.